rates being proportional, okay? Both of the last 2 days of Bellworks are very important for this. And so today in Bellwork, we did this right here, where we started with this equation, which is just a fancy version of y equals a e k t. When we set up this problem, the a sub 0, that is our initial amount. So whatever you started with, that's going to go right there for a. Your k is going to be a growth rate. It is not a variable. You have to find your k. The k tells you how much it is growing or decaying. If your k is positive, it's a growth rate. If it's negative, it's a decay rate. Okay, it's normally a decimal of some type. And then t represents time. I did a half-life problem here. It's worked out for you. You can go back and look at it if you need it. Yesterday in Bellwork, we talked about a rate of change being proportional to some number. If you are proportional, that just means you're multiplied by it. Okay, so in this case, our rate times y, if we separated, we integrated, we solved for y, we found out yesterday in Bellwork that that gave us this right here, y equals a e k t, the same formula we've been doing. Those two concepts together are going to build our lesson for the day. It is not calculus, it is very much pre-calc. Okay, first two problems, all we're doing is setting it up. So it says for part, or example 1, a kitten weighs 85 grams at birth. During the first 4 weeks, its weight is given by the function w, so weight is a function w, that satisfies the differential equation dw dt is equal to kw, where t is measured in days and k is some positive constant. Which of the following could be an expression of wt? They did not give you enough information here to solve it. Okay, we don't know what the real equation is. All we are doing is what could it be? So when we look at this, they tell you that the weight satisfies that differential equation. dw over dt equals k times w. That's what we know. That is a proportional rate. We want to know which could be w of t, or in other words, we want to go from the rate to an amount, w of t. So what do I need to do with this rate to make it an amount? Integrate it, find the antiderivative. Well, we already know what the antiderivative of this is going to be. If we start with this, what is the antiderivative going to be? Y equals a e k t. I use w because they told me weight, but just make it y. What thing do we know? What's the a is the starting amount. So what is my starting amount going to be for my weight? 85 grams. And so right here where a is, it's going to be 85. The next thing I normally would do would be to solve for k, but they didn't give me any other information, so I can't really do anything with it. Based off of that, which one could be an answer? A. It's the only one that makes any sense. It's the 85 here to that 0.05, 85e to the 0.059t. It's in that form, y equals a e k t. Makes sense on the first one. It's that easy. Try example 2. See if you can do the same. Show me with your fingers. 1 for A, 2 for B, 3 for C, 4 for D. What you get? 1 for A, 2 for B, 3 for C, 4 for D. We're seeing a lot of ones. Let's make sure that that is true. We've got this equation. You get 400 milligrams of drugs. There's those drugs in your bloodstream. The rate at which it leaves is modeled by this equation. I want to know just A of t, so I'd have to take the antiderivative, which is going to give me A of t is equal to A e k t. I know I'm starting off with 400, so that's going to go right here. That's the only one that makes any sense. Questions on that? Let's do it again. In example 3, it says during a chemical reaction, the rate of change of the amount of the chemical remaining is proportional to the amount remaining. At time t equals 0, the amount of the chemicals is 12 moles. At t equals 4, the amount of chemicals is 4 moles. At what time is the amount of chemical 3 moles? Okay, so a lot of things are going on there. The big thing that I underlined there is the rate of change is proportional. The rate of change is proportional, or in other words, the derivative, dy over dt, is going to be equal to some rate times y. That is what that means. That phrase, the rate of change is proportional. Means that right there. Everybody okay with this concept? So let's find some other things they told us. They said at time t equals 0. So when my t is 0, how much of the moles is going to be left? 12. So at 0, I'm going to get 12. At 4, how many moles am I going to have left? At 4, I'm going to be 4. At what time is the amount of the chemical? 3 moles. So I want to know 3, comma something. Using that alone, you can probably narrow down a little bit of what the right answer is. What do you think the right answer is going to be? It has to be, it went from 12 to 4. Now it's going to be less than 4. Oh, we are asking for the time. Good. I'm glad we didn't do that. That'd be dumb. The answer's D. I got you. Burned. You're figuring out when you have 3 moles, so you're trying to figure out 3. Now, the answer is going to probably be D, but we can at least eliminate A. It's not A. Okay? We know it's not A. My fault. Everybody understand this concept? I didn't mean to screw you up there. All right. So they told us a rate. We want to know an amount of moles. What do I need to do with that equation to find an amount? Integrate it. We can skip the whole separate, integrate, everything else because I have this right here. I know it's going to be y equals AEKT. I need 2 points at any time in order to actually get a solution here. And so what's my starting amount? 12 E. I do not know my K. They did not tell me the rate anytime in this problem. So K is still K. And then I need to plug in some time and some Y so I can find my K. So what other T and Y can I plug in here? 4 and 4, because I know that my T is going to be 4 and my Y is going to be 4. No, we already used 0 and 12. We don't want to use it twice. Okay? Solve for K. Go. If I want to solve for K, Kate, what'd you do next? Divide by 12. Cool. We've got 1/3. Then what did you do? Then we're going to take the natural log and divide by 4. So K is equal to whatever the natural log of 1/3 divided by 4 is. That's my K value. Okay, that is not the answer to the question. That's just a K. Once we find our K, we are then going to plug it back into this equation and solve for the other thing. I know what A is as well. I know A. A is still going to be 12. So now we've got this formula. Y is equal to my A value, which is 12. E, natural log of 1/3. You could plug it into your calculator and figure it out. I'm just going to leave it like this because it's probably just as easy to type into my calculator. Times T. I want to now find this. I want to know what time is it when the moles are 3. So what am I plugging 3 in for? Am I plugging that in for Y or am I plugging that in for T? Plug it in for Y. Solve that thing. See what you get. No, it was like a month in. 3 equals that thing right there. If I wanted to solve it, Eddie S., what do you need to do? If I'm solving for K or solving for T now with that equation right there, what am I going to do next? Divide by 12. Divide by 12. So now he's got 1/4 equals E to the 1/4. Natural log 1/3 T. Get rid of the E. So now we're going to do natural log on both sides. Natural log. That's going to cancel. I'm then going to divide by whatever you got for K. I just left it like this, but you could have gotten a value right there because it's going to be a little bit easier to deal with. All right, but in my calculator, you are taking the natural log of 1/4 divided by 1/4. I got to be careful how I type that in. Divided by 1/4 natural log of 1/3. I type it all in. I hit enter. I get an answer. 5.047. My answer is D. If it's easier for you to get the K value here instead of leaving it like that, do that. Give a decimal, leave it in your calculator, that's fine. I don't particularly care which way you do it. Questions on that? These don't always have to be calculator questions, okay? This technically could have been a non-calculator question because I didn't need a calculator to get to my final answer. You might have to do some manipulation at the end, but I figured today would be easier if I just made it a calculator version instead. Let's go to example 4. Stay with me, please. Oil is being pumped continuously from a certain oil well at a rate proportional to the amount of oil left in the well. Okay, so rate proportional to the amount of oil left. That means that dy over dt is going to be that equation right there. Initially, there was 1 million gallons of oil in the well, and 6 years later, there were 500,000 gallons remaining. It will no longer be profitable to pump once we've got less than 50,000 gallons. So for writing ordered pairs of what we know, at time t equals 0, what's my value going to be? 1 million. At t equals 6, 500K. I've got some numbers. We are trying to write an equation for y in terms of the amount of oil remaining at any time t. So we're writing an equation. So in other words, we are trying to plug in for both my starting amount and my K. That's what I'm trying to do here. They gave me this proportional rate. I want to make it Y. What do I need to do with that proportional rate in order to make it Y? Integrate. What's that integration going to be? The same thing we've done on every one. Y equals AEKT. Plug in, solve for K, and then just rewrite your equation with K plugged in. That's what you're trying to do here. See what you can do with that. Y equals AEKT. We're trying to plug in some stuff. Ella, what'd you plug in here? Okay, so she is going to plug in 500,000 because that's going to be her ending amount. What else can we plug in here, Logan? What's my A going to be? 1 million because he's starting with 1 million. What else can I plug in here, Jason? 6. What's that going to go for? T. My T is 6. By doing that, we've got everything plugged in except for K. We're then going to solve for K. So that means I need to divide by 1 million. 500,000 divided by 1 million, that is 1/2. We're going to get rid of E, so we're going to take the natural log of both sides. We're going to divide by 6. K is equal to that number. If you want to, for this problem, because I'm not being real specific, you could just type this in. Natural log of 1/2 times 6. Am I times 6? No, I'm divided by 6, correct? Yeah. Divided by 6. Type it in, hit enter. Boom, there's my answer. It's that negative 0.115 number. Okay, we don't want to round it, though, if we're doing calculus. And so my final answer, write an equation that'll get you the answer with any time t. It's going to be this. Y equals 1 million e to the 1/6 natural log of 1/2 t. That is the answer to this question. I have now written an equation that's going to set everything up. Questions on how we did A? Part B is easier. Read part B here. It says, at what rate is the amount of oil in the well decreasing when there are 600,000 gallons of oil remaining? Include units in your answer. At what rate? What am I going to use to figure out what rate do I have? The derivative. We're going to use that equation that we had, which they said was this thing right here, that dy over dt equals ky. dy over dt equals ky. Figure out at what rate is this happening. It should be pretty easy. If you think, man, that was really easy, you're doing it right. Anybody confident in what they did here? Don't overthink it. I'm trying to figure out the rate, so I'm trying to figure out this right here. Do we know what my K is? Yeah, we just found it. It was that number up above. It's this thing right here, the natural log 1/2 over 6. So the natural log of 1/2 over 6 times my Y value. Well, what's my Y value going to be for this problem? 600,000. Type it in my calculator. That number that I got right here times that thing times 600,000. I hit enter. That's going to get me negative 69,314.718. Negative 69,314.718. Yes, in theory there, yeah. That is, it's telling me it's decreasing because it's negative. Negative means it's decreasing. So yes, if you want to get specific there, we could just say it's decreasing by that amount. What would my units be there? It's a derivative. It is my amount, which is gallons, over years. So every year we're losing 69,000 gallons. Makes sense on B, or not every year, but at that time, at that very specific time, it's that. Letter C says, in order to not lose money, at what time T, so we're looking for T, should the oil no longer be pumped into the well? If you remember back from part A, it said after 50,000 gallons, it no longer made sense. You have an equation that told you exactly what the formula was here. It was Y equals that 1 million. I'm going back to that part A equation. The part A equation that we found was this thing. You want to know when should you not put in anymore or pump anymore? They told me after 50,000, it didn't make sense to pump the fuel anymore. So where am I plugging 50,000 for? Why? Solve it. Here we go. It shouldn't be too bad. All we had to do is plug in the 50,000. We divided by 1 million. Then we take the natural log of both sides. Then we're going to divide that thing by 1/6 natural log of 1/2. And that is going to get me T. So in my calculator, the natural log of 1 over 20 divided by that negative 0.1155 number that we got from earlier. We hit enter, 25.932 years. Questions on how we did the oil problem? Again, they're all pretty much the same. You have a rate proportional, you're going to separate and integrate, do all that good stuff, and then work from there. Let's try one more together here. Try number 5, see what you got. So first thing I'm going to do is make some ordered pairs. So if I look at this thing, the volume of the cube is increasing at a rate proportional. That is how we know we can do all of this stuff. dy over dt equals yk. And so then if we did that, we would get y equals aekt. All right, you could use volume and v and some other things if you'd like, but that's what we're going to do. No, you don't have to. And so this is going to be a multiple choice question on the AUP exam, so they're not going to look for all of that. If the volume is 8 cubic feet originally, then that means at t equals 0, we're 8. At t equals 5, we're 12. What is the volume at t equals 12? Those are the things we're looking for. We plug in what we know. And so it's going to be 8 E K, and then I'm going to plug in a point. So I'm going to plug in that point right there. So 12 is going to be my ending amount, and my time is going to be 5. So in my calculator, 8 divided by 12, or 12 divided by 8, that's 3/2. So then I'm going to take the natural log, and I'm going to divide by 5. And so in my calculator, I'm taking the natural log of 3/2, and I'm going to divide that answer by 5. That is my K value, 0.08. It's positive. Does it make sense that it's positive? Yeah, because my numbers are growing. 8 to 12, it's going to be something bigger than 12. Okay, then we're going to work from there. What is the volume at t equals 12? Well, I've got my K number, so then I'm just plugging in. Y equals A, still 8. E, K, that 0.081 number. And then my T, I want to know what is it after 12 seconds, so guess where that 12 goes. T, 8e to that number times 12. So in my calculator, I'm taking 8e, that number, times 12. Type it in, hit enter. 21.169 is the final answer to that question. That is the volume at T equals 12. Questions on something we did today? Yes, sir.